Now we have to obtain the operation points of this circuit. And remember that the operation point is to know all the voltages in all the nodes of the circuit and all the currents in all the branches of the circuit. This is called the operation point. So we are going to identify the node of the circuit. We can see that we have I'm going to use this node, and this one. We have three nodes that I'm going to call node 0 for the ground, node 1, and node 2. So we have three nodes. And how many branches? We are going to have one branch. You know that the branches are all the possible paths between two different nodes, and all this is node 0, okay, because there is cable in the middle, not elements. It's the same node. So we have one branch, two branch, three branch, four branch, and the fifth branch. So we have five branches. So if we have, I'm going to delete the colors. So if we have 5 branches, we are going to have 5 unknowns. Which are going to be our unknowns? Sorry, it's difficult to write with this pen. So the unknowns are going to be the currents in the branches where there is no current source, and the voltage of the current sources in the branches in which we have current sources. So in this branch we don't have a current source, so this is going to be, for example, current 1, and I'm going to choose the directions I want. In this second branch we have here a current source that is controlled. You know that there is a current source because we have an arrow inside, but it's controlled because the symbol is just a rhomboid, okay? It's a diamond, the symbol. So here the unknown is the voltage of this current source. I'm going to write it like this. That is the way we are used to. In this branch we don't have current source, so we have another current that I'm going to call current 2. And in this branch we don't have either current source, so we are going to have another current that is going to be current 3. And in the last branch we have a current source that is independent because the symbol is a circle. So the unknown is going to be the voltage in this current source that I'm going to call voltage V. Okay, so once I have assigned the direction of the currents, I have to set the polarities of the resistors. Remember that the plus sign is going to be in the terminal of the resistor where the current enters. So we have a plus here, a plus here, and a plus here. So we have all the polarities and all the currents. We can start applying the Kirchhoff laws. So we are going to start with the Kirchhoff currents law, that is the first one, and we have to apply this law to n-1 nodes, to 2 nodes that are going to be the ones that I choose, the one that I preferred. So for example, I'm going to choose node 1. Node 1, we have that I1 enters, and the current of the control current source is this, okay, that is entering as well, and the current that exits the node is current 2. We are going to get rid of this as fast as possible. Which is this voltage? This voltage is the one that the one that we have in the resistor, that applying the Ohm's law is 3 multiplied by current 3. Do you see because we have that the plus sign of the voltage is the same as the one of the resistor, so it's exactly the same. So we can replace this term by this. So we have the equation 1. Okay? And you have to get rid of this intermediate variable as soon as possible, so the equations are clearer and less confusing. So we applied the first Kirchhoff law to the node 2. In the node 2 we have entering current 2 and the current that comes from the current source, and exiting the node we have current 3. So we have the second equation, equation 2. I'm going to write equation 2 as I wrote before. So now we are going to apply the Kirchhoff voltage law, or the second Kirchhoff law, that of the voltages, that of the loops, and we have to apply this law to the number of branches minus the number of nodes minus 1. That is going to be these 3 loops that we can choose. I always recommend to choose the loop formed by each square of the circuit. It's going to be simpler. Remember to use a clockwise directions. I choose M from mesh, but I'm going to choose better L from loop, because loop is a more used term in English for this kind of circuit analysis. So we start with loop 1. So remember that we are going to cover of the loop, and the voltage of each element is going to be positive if we leave the element by its its positive terminal. So we are going to have 7 volts because we are leaving the voltage source by the positive terminal. So minus, we are going to apply directly the Ohm's law, minus 1 by the currents, minus because we are leaving the resistor by its negative terminal. Now we have to add the voltage of the controlled current source, and this is important. This is not a voltage. This is the current that the current that the source generates, and we have used this in this equation because it's the current. Now we have to look at the voltages, and in fact here we have the voltage of the current source, and it's an unknown of our system. So we are leaving the control current source by its negative terminal, so it's going to be negative and equals to 0. So equation 3. Second loop. We are going to start here in the ground node. So this time we are going to leave the control current source by its positive terminal. So voltage A is going to be positive. The resistor is going to be negative, and the other resistor is going to be as well negative, and we have finished the loop. And finally we are going to look at loop 3. So we are going to have that the voltage in the resistor is positive because we are leaving the resistor by its positive terminal, and we are leaving, and the other voltage is going to be the voltage in the independent current source, that is another unknown, and this is going to be negative because we are leaving by its negative terminal. So we have the equation here, and this is the equation 5. So we have 5 equations and 5 unknowns. So we can just solve the system, and we're going to have all the currents and all the voltages of the circuit. So you can do the rest if you have time.